Welcome to the last chunk of this three-part series on high-level frameworks that sort of took a educational vector on making you understand how training frameworks work and really about learning. It's been fascinating watching how this has evolved over three lessons. So today is the conclusion where we talk about briefly how high-level frameworks work for you, and then I'll open the floor to Q&A. We can chat about sort of everything that's happened over the last three sessions and get into the nitty gritty as much as you guys want to. So the story so far, right? What have the last two lessons been? First, we began with high-level frameworks. They're mostly aimed for beginners. They tend to be a bit more on the magical side, right? They try and wrap as much as they can to give you one-line solutions. In doing so, they tend to be a lot more difficult to debug, and as a result, people find them very frictionful. However, even though those are all negatives, the big proponent and intrigue into high-level frameworks is they get you started with an applied problem, right? They get you into working with data, into working with models, and getting your feet wet. From there, we journeyed on to low-level frameworks. So these typically are less magical on purpose, right? They're aimed to wrap around the light areas that you might need to touch occasionally, but you don't particularly want to. So we don't abstract the training loop. We abstract sharding a data loader to where it sends the data across all the GPUs. But our training loop still works the same. On top of that, these tend to be problem-oriented solutions. So typically, this means that we've identified some area where people are struggling with in terms of bootstrapping their data loader, making issues with unnecessary slowdowns and high-level issues, right? So the example that I gave yesterday was gradient accumulation and excess communications, right? And sort of solving that under the hood without abstracting too much from a user's training loop. And then most importantly, the part we spent quite a bit on yesterday, or on Wednesday, is using the low-level frameworks as education vectors. So taking the high-level framework that got you interested into the low-level framework where you use that as a guide to learning everything you can about what that framework does. So where does that leave us today? High-level frameworks, again. Now, the reason why it's again is what you'll find is most experts use pretty high-level frameworks, right? I showed an example where Stas uses Accelerate wrapped in his own high-level training framework to get things done. Internally at Hugging Face, right? People tend to use TRL. I love using Axolotl for all of my training, needs. And why do we do this? Well, after you've been through the weeds and after you understand how it all works and you understand the full picture of where certain interactions should be happening, then debugging becomes a lot easier. The example from the first lesson where we talked about getting a matmul issue and not understanding where that happens, why that happens, and whether it's from the model or from the code and whatnot. Well, now we know immediately, well, that's from probably the data that was wrong. So I'm going to go look at where the data is and where the model gets called. So it's easier to understand where these issues are stemming from. And on top of that, right, once you understand where the issues stem from, you can also help bring up those new users that were facing the same issues you were by giving them a method to go and discern the madness. Right? On top of that, it's easier to hack away at problems. Once you know where a problem is, right, you don't have to sit there and wait for someone to go implement something, for someone to go close a bug fix or patch a PR, right? You know directly where to attack, you know how to put a monkey patch in there, and you're on your way. The biggest example of this is anytime I face an issue in a framework where I don't like it and it's very niche to my own problem, I will actually bring in a dash of magic and use FastCore's patch decorator, which, yeah, sure, we can go do a quick FastCore. We can do a quick detour. So if we do patch, patch is quite literally monkey patching, right? It's a decorator where you define a function and the class it stems from. In this case, this is class A and B, and it will update the code that class references. How I tend to use this is I will call patch, open the source code for whatever function I want to modify, copy, paste, and update. Usually this is if I'm interactive in a notebook or if I'm trying to modify it in the direct file. And the benefit of this is all of my edits are localized, right? So I know what I'm changing. And also I know that I'm overriding the code directly, right? You're not going through and modifying it in one Conda environment and hoping it modifies it in another one. Now, if you're working directly out of a Git branch, then you use the Git branch edit, right? Because you copied it for a reason. But if you're just getting started with hackifying a framework, FastCore's magical library is very handy for those very specific purposes. Now, what that also means is, let's say that there's a particular problem you want to solve, but a framework doesn't let you do that. What can you do? Trainer doesn't do what you want. You're trying to do reinforcement learning or something, and the current solutions out there don't quite fit what you're trying to do. Well, then make your own, right? You could fork the repo, modify it, and publish that. Now you have a little library with a particular task, advertise it, and you've shown that you're capable of doing something. You have both solved your problem and demonstrated to others why you solved the problem in this way. Eventually, they might not upstream that issue, and that's okay, because you've got it hosted in your own world for everyone to benefit from. Also, this gives you a variety of freedoms that typical library maintainers aren't able to have. For instance, you might notice that Ray and Accelerate work very well together, but you know that Accelerate will not allow external dependencies, and there are certain tweaks you need to make for it to work with Ray. Then make Ray Accelerate. Make a package for it, right? There's nothing stopping you. It's a great way to educate yourself and others on the subject, and you've also solved your own problem, right? And this is sort of the ground roots of open source as a whole, right? It's how you go from a user to, on one hand, we could say developer. On the other hand, I would say expert, in quotes, because no one's truly an expert. But you become someone very knowledgeable on a subject that others can look to as a resource to learn from, right? There's no reason to say transformers won't merge X, so thus it's a bad idea and I should stop. You had the idea. You wanted it implemented for a reason. Trust in the reason and do the thing. People will naturally gravitate towards that thing because you do not, in of yourself, live in a bubble. There's hundreds of thousands of developers. There's a gigantic community of people doing machine learning, and there's probably more than one other person that has run into the same frustration you have where you solve that problem. So once you're able to get past that point and you can think about how you want to publish this and market your idea, you can do whatever you want with it. You could completely gut the trainer entirely and release, like, here's a 100-line of code trainer with all the fancy stuff ripped out, and it just uses Accelerate in its absolute core parts. That's cool. I've always wanted to do that, but I've been kind of landlocked into the trainer as it is. That's fine. Go do it. Rip out the code. Do everything you want. Copy your ideas with attribution that it's designed after something, because open source community relies on healthy relationships. Publish it, and then hear back from others. I love reading about people that have taken Accelerate and built their own mini training frameworks off of it. There's at least half a dozen that I know of. 3 of them are actually quite popular. And it's a great way for you to get feedback, not only from users, but like, we notice it, right? So we'll look at that and go, okay, so they did it this way. Why? And then that makes us think about how we can change the trainer a bit. And most importantly, right, market and identify the problem your version solves. or make your life from 5 months ago easier. Just to sort of reiterate, if you really want to get at the root of taking this idea, this learning curve, and getting something packaged you can put on a resume and prove to the world and say, hey, I did X. The easiest way to do this is start with one framework that you know very well, right? This could be the trainer, this could be Accelerate, this could be Lightning, it could be TensorFlow, doesn't matter. Identify what areas you had issues with, right? You had troubles with, pain points, frustrations. Then solve those issues, right? Solve the first one and then continue. And every time you do, market the heck out of it like your life depends on it, right? Think of it as stating your resume to the world. I did this. This is important. Take notice. Eventually, people will notice. Fun fact, that's what Unsloth does, right? They're a phenomenal framework with battle-tested, essentially bug fixes for the trainer, right? They wrap around the Hugging Face trainer, but they have their own implementation where they consistently solve the bugs that we're not able to immediately. And then we solve it within a few days, but this is how their marketing goes. And there's a way to do that healthily because we have a wonderful relationship with Daniel and everyone at Hugging Face, right? This is not like making a war out of a singular problem. It's very easy to do that. So you have to be respectful and careful of how you market things. But that is the eventual end goal, right? With everything in your career, you want to market yourself towards a particular paradigm, to a particular idea, to a particular strategy. And so build up this resume of problems you've solved, solutions you've made to present to an interviewer and say, hey, I started my journey a year ago where I took transformers out of the box and was training things. And then I went and investigated a little more. And now the end result is I have my own version of TRL that does these particular things differently because I found these particular frustrations and things that I couldn't do with just transformers. Holy cow, that is an impressive resume that most people that are interviewing you for internships and whatnot will be absolutely excited about. So with that, sort of an early conclusion, right? Because we're about 15 minutes in to this 3-part series on, I don't even know what to call it anymore because it started with API design, turned more into a career guidance on the open source ecosystem and why just being a machine learning engineer is not enough anymore, right? You need to understand these API frameworks inside and out and understand why they're doing what they're doing. And really, especially as open source is continuing to boom, be able to provide the evidence to show that you are an exceptional human being who has novel ideas that work very well. And applying it to training frameworks in particular is one of the strongest ways to get there, in my personal opinion, because there's a million training frameworks. Every single one of them has a particular opinionated design choice in mind. And so every single one of them have strengths and weaknesses built upon that opinion. And that's okay, right? That breeds innovation, that breeds competition, that breeds ideas and collaborations as we all basically study everyone's psychology and understanding of how API should be built. So thank you guys so much for coming. I will open the floor to questions. Please feel free to put them in the chat. Can be career advice, can be just ideas on frameworks as a whole. However, there will not be a lightning lesson next week. I'm going to be focusing on taking all of the recordings and publishing them to YouTube, which will take me a chunk of time. That way you guys can actually find these easier after the fact. But feel free to send me some questions in the chat, and we'll take 5-10 minutes for you guys to think about them. But thank you so much for coming. Let's see. Well, first, yes, I have not given permission. Ask your questions in the chat specifically. It's easier for me to read that than it is to think about your voices whenever I'm editing. Victor says, thanks, Zach. I missed part 1 and 2. Will you be putting those on YouTube then? Yes, also in the follow up to this email, I will give you links to the other two recordings. You might also get emails if you signed up for this one specifically and you didn't sign up for the other two. I will automatically be adding you to the prior ones. That way, while I'm going through and editing this, you will have access to the prior two lightning lessons and their recordings. Very good question. How can I make the best use of the Scratch to Scale course? I've only trained models using the Fast AI Trainer back in the day. What do you suggest as a beginner to do in 1 month? Ooh, solid question. Get a little more comfortable with low-level frameworks, right? Use Accelerate a bit, use regular PyTorch. However, as long as you've done training before and you've been coming to these sessions and you've been reading, the Mueller minutes, and most importantly, you've read the distributed lexicon or at least given it a glance, you're doing pretty good. Another great resource is the UltraScale playbook, which I will continue to plug. It is the Nanotron large-scale training playbook that talks about distributed training from the guise of training DeepSeek. Now, you'll notice that it covers a lot of the same material the course does, and that's perfectly fine. Like, I'm more than happy to have more resources. I will say theirs is more math-oriented. Mine is more code-oriented, which is why we're doing it this way. But both work very well together, in my opinion. They're making a physical course for the book, and I 100% have already signed up for the pre-orders. I'm going to be tracking down all the authors to try and get it signed, because this alone is a wonderful knowledge source. Let's see. How can we become more engineer-like? Think of it this way. I'm out of school. When I look at a big code base, I don't understand anything. Are there any ways to onboard big systems? That's sort of what I've been talking about, right? You just attack one problem at a time. You play with it, you tweak one thing, and then you move on to another. When I was doing this in college, that meant I was playing with FastAI every day for 2 to 4 hours a day, and I would just train things and break things and play with them. Because unless you sit there and play with it for long enough, you don't notice some of these issues. And then that gives you paths to learning and whatnot, right? We don't go and just scroll through the code base aimlessly trying to learn what every little line means. That's useless. Do it in an applied format where naturally, as you're progressing through different ideas that both work and don't, you learn more and more chunks of the big pie. I remember Jeremy did a live coding long back. I love the series. Can the new course incorporate some from that memes course? Yeah, it probably not, just because personally over time I've found Jeremy's methods to be a bit more magical than I'm comfortable with nowadays. So the course will come up with rudimentary solutions to like Zero and Pipeline, but they're not going to be magical in any sense on purpose. But it is a wonderful book on wonderful series on hacking through frameworks and debugging and what the real world dev is like. That's not the pretty pictures. How to look at the lexicon, great stuff. Would it be possible to get the references you used to put that together so we can dig deeper if needed? Probably not, because that lexicon was built off of like 500 different references that I was digging through late at night. So I sadly do not have that list anymore. The main animations, I do have their source code. I might open source that one day. Oh yeah, of course, Stas's book. Stas's book is phenomenal. Stas's ML engineering book. The other one I always try and plug every time we do this. It is a complete guide to everything Stas has learned over the years training big models. So it covers everything from network to orchestration to guides about what training is really like, debugging. How do you think about the compute you're using? How do you make sure you're using them the best? How do you measure T-flops? What even is a T-flop? So the ML engineering book is also a wonderful supplementary resource. I will say when it comes to these big resources, be it the UltraScale playbook, the ML engineering book, and especially what's going to be my course, because if you saw recently, I made a little tweet where I chart mapped everything that happens with the course, and it's a chunk. And so take it section by section, subject by subject that's interesting to you, and always start there and then explore outward, right? If you try and learn everything at once, you will learn nothing. So be very targeted and careful about how you approach the content and the materials. That way you don't burn yourself out from learning too much. When I think about Jeremy's deep learning from the foundations, which is, the course that I consistently say that I love the most out of everything, this one in the part 1, I went through this course in like 2 years, right? Between the first and the second course, it took me 2 years to go through the entire thing. There will be a second cohort well before 2 years. I'm aiming for the second cohort to be like somewhere towards the start of the year where we talk about post-training. But the aim that I've been trying to do and all these resources do is give you enough to where, if you dedicated 3 to 4 months of your time solely to it, you'll be able to learn everything. My aim is to give you enough stuff to where it's not something where you spend 15 minutes, oh, I got it, it makes sense now, and then you move on. The aim is to give you content that you can learn from, help you become an expert, and truly grasp all of these fundamentals. Which is why I really recommend these 3 resources as supplementary. Like the deep learning from the foundations, if you want to go further into library development or understanding PyTorch as a whole and whatnot, this is the course to do, in my personal opinion. Yes, it is 6 years old at this point, and that doesn't matter. I've taken this thing back through again 3 times. The last time was, I think, like a year ago. Just because the ideas and how all of this happens is extremely knowledgeable. It's extremely packed, but it's extremely knowledgeable. And every once in a while, it's good to revisit it all. So yeah, very good questions. After this, I will send out a discount code for 35% off the pre-order price for the course. You should have gotten an email about this. However, good question. How does your walk with code join up with deep learning from the foundations? Consider deep learning from the foundations the lowest point. So deep learning from the foundations is essentially building PyTorch from scratch. Like, here's an area where they essentially do the high-level overview is recreating the FastAI framework. And then you deal with matrix multiplication, TorchNN, Optim, dataset data loaders, and everything that comes along with it. It is not focused on distributed training, but it's a wonderful way to strengthen your ground knowledge on machine learning, PyTorch as a whole, deep learning as a whole, and boost those soft skills by giving it solid foundations of learning how this all works. So it's not a lead in, or it's not an after, and it's not supplementary in the sense of you need to use this knowledge to do the course. However, it is purely the course that has started me on my career. So given that, I will plug it any day I can and highly recommend anyone take it that can, because it's free. It's, I think, probably 6 lessons that matter. So it's 12 hours of content or so with a bunch of notebooks you can run. So it is one of the most valuable resources that Jeremy has put out. So yeah, there will be a discount code because price is starting to go up. We are now a month away from the start of the course. However, the discount code will make sure that the price for you is always $975, which is the pre-order course price for the course, and then that will change the second we go live. Never mind. You are very educated on my content. I was referring to your Walk with Code series you did 3 back. So that one is more a targeted learning. For those who don't know, one of the first courses I ever did was Walk with FastAI, where I did Walk with FastAI, and then I did Walk with FastAI Revisited. With the idea being there's the FastAI framework by Jeremy, and I take a problem by problem approach to every single lesson on breaking apart the framework and getting you used to doing things in PyTorch that FastAI does itself, along with some customized areas that FastAI doesn't do. It's a bit different than deep learning from the foundations because, again, it's supplementary, right? It's purely supplementary. I never go that low in level. This course will actually be the first time I've done that from a teaching perspective because we're, recreating all these from scratch. But this is more a course on giving you my experiences that I've done with machine learning and deep learning as practical problems and using that as the vector to guide you through understanding what's happening under the hood in the FastAI framework a little better, which gets down to that low-level API, but does not go down to PyTorch itself. So that's, again, sort of why, from the foundations is a separate golden child in my head because it's phenomenal. Good question. And thank you for the clarification. Okay, well, I don't believe there are any more questions. So in the meantime, enjoy the recordings if you have not watched any of them. They will all be on YouTube, and I'll tweet about it and shoot an email. Hopefully by the end of the weekend is what I'm aiming for. We'll see how that goes. But otherwise, thank you guys so much for sticking with me for essentially a full week of 3 lessons talking about how I learned frameworks and how, I think it can help you. So thank you all so much for coming. You should see a follow-up email in later tonight or tomorrow with the recording edited, but you will also, I will make sure immediately after this to go sign you all up for the prior Lightning lessons so that you can go get those recordings. Thank you all so much for coming. I will see you all in 2 weeks.